Hello, geometry people. Well, the good news is we're going to move on from the Pythagorean theorem. Our next topic is similarity. Similarity means that two geometric objects have the same shape but a different size, and we call them similar. And it turns out if they're similar, their sides are in proportion. So we're going to spend a day solving proportions first. Now, to begin with, let's say what a ratio is. A ratio is just a comparison of two numbers using division. A ratio can be something like 3 to 4. We solved a lot of ratio problems earlier in the year, and you were told to put x's on them. So if you're given a problem like the ratio of the three angles of a triangle are 2 to 3 to 4, you put x's on them, 2x, 3x, 4x equals 180. Now a proportion is two ratios set equal. Two ratios set equal. So, for example, 3 to 4, now that's another way to write a ratio. And you can see it's written as a fraction, and a fraction means division, so that's what I meant when a ratio was two numbers compared by division. 3 to 4 equals 6 to 8. That's a proportion. Now we're going to be solving proportions. So let's do a couple of examples. If we're going to solve them, these proportions must have x's in them, right? So you have x over 21 equals 2 over 3. Now, the way I want you to solve these proportions is what we call cross-multiplying. Now, when you cross-multiply, it means you multiply the 3 times the x, and you get 3x. You set that equal to 2 times 21, and you get 2 times 21. This is called cross-multiplying. This is just an illustration of how it's done. For some reason, in the past, students have done this and only this and think they've cross-multiplied. Now, cross-multiply means you actually multiply. So we're going to now solve this. 2 times 21 is 42. Divide by 3, and you get x is equal to, well, how many times does 3 go into 42? 3 goes into 42 14 times. So our proportion now becomes 14 over 21 is equal to 2 over 3. Now there's several ways to check a proportion. One is you can multiply 14 times 3 and then 2 times 21 and see if they're equal, and you will get 42 each time. Another way to do it is to reduce the 14 over 21 and you get 2 over 3. And a third way with a calculator, do 14 divided by 21, you'll get 0.6 repeating. Do 2 divided by 3, you get 0.6 repeating. So now let's just do a couple more proportions. Let's do another one. 2x plus 1 over 5 equals 3. Well, at first you may think this isn't a proportion because that doesn't look like a ratio, right? However, the number 3 is the same as the number 3 over 1. You can put 1 under any integer, and now it is a proportion. So if I cross multiply, I get 5 times 3, which is 15. You could have written down 15 if you wanted. And 2x plus 1 times 1. Well, anything times 1 is just itself, so it's 2x plus 1. 15 equals 2x plus 1 minus the 1. 14 is 2x. Divide by 2. 2, you get 7 is x. So what we're saying, if we plug that 7 in, 2 times 7 plus 1 divided by 5, does that equal 3 over 1? 2 times 7 is 14 and 1 is 15. Does 15 over 5 equal 3 over 1? I think it does, because what's 15 divided by 5? It's 3. Alright, let's just do more. let's say x plus 3 over 12 is equal to 3 over 4. So we're going to cross multiply. We're going to do x plus 3 times 4. All right? So 4 times x plus 3. 12 times 3. Be careful when you're multiplying 4 times x plus 3. Do this first because that will remind you that you have to distribute. 12 times 3 is 36. Let's minus the 12. 4x is 24. Divide by 4. X is 6. Okay? And if we plug the 6 in, we get 6 plus 3 is 9. Does 9 over 12 equal 3 over 4? Yes, it does. So how do you solve a proportion? You cross multiply. I believe this is probably review. I hope this is review for you, but just in case you need a little memory refresher, we are spending a day on solving proportions. Okay? Let's